it's just mind-boggling how complex semiconductors are and like how difficult it is to produce these chips. Like if you are in the if you're an engineer like at TSMC, there's like this single task, like you're just turning this one knob on this one machine, and like you're the only person in the world who knows how to turn this knob, or like it's more like 120 knobs, and like you're the only person who knows how to turn these 120 knobs, and like no one could replace you because no one like it would take like decades for people to learn what you're doing, and like what China is doing right now is like replacing every single person who is like turning dozens of knobs and like trying to kind of bootstrap to decades of experience in the semiconductor supply chain. So I think this is like a real challenge. And Chinese people are like super talented and like really smart, and like they have a lot of industrial power. So it's like not like this isn't something that China will never be able to achieve. But just given how complex the semiconductor supply chain is, it will take China years to get where the rest of the world is right now. And by the time that China gets there, the US will probably already have like a newer generation of chips and new generations of designs, etc. So hopefully, like the lead can be sustained this way.
Right. Yeah, I've heard this like a bunch of times before that like the complex machinery of this is like so incredibly vast, and like there's only one person who can do this job. But like it's I don't understand how that can be true. Like with your naive example of like just turning a knob, surely you can have like a PID controller for that or something. Like that person can write down a couple of notes or teach an AI to do it for them or something like this. What is it possible to paint a picture to make my brain understand how
Yeah.
hard it actually can be?
So I think like rather than turning knobs, it's like setting up this machine and calibrating it properly, etc. And it's like so one really important thing in semiconductor manufacturing is yields. So like as you're like you have the wafer and then you get like a fraction of the wafer is becoming chips, so like you're cutting them out at the end. And the better you are at your job, the higher the fraction of chips that actually work at the end. The worse you are, the lower the yield. And like what China is achieving right now is maybe like we don't really know, but maybe like a 10, 20, 30% yield. What TSMC is achieving is like 70, 80% yields. So like they're just so much better at making sure to actually get these chips out. And what like there's so many things that affect the yield. One thing is like, and whenever you're entering like a semiconductor fab, you have to wear like a full body suit that's like preventing any like even a tiny flake of skin or like a tiny piece of hair so to fall onto the machine, because basically if that happens the whole charge is like ruined, like you don't get any useful chips out. And the same is true for like all the setup in the machine. So they have like incredibly precise lasers. There's only one company on Earth that can produce a laser, and like the laser is so precise that like you could, if you were pointing it at the moon, you could hit someone's thumb on the moon. That's like how precise this laser is. And then the mirrors for like the laser is like being reflected like 12 times or something to be like in exactly the right spot. And the mirrors are so smooth that like if the Earth like surface was the mirror, then the biggest like impurity on the mirror would be like a centimeter or something like that. So it's like crazy like how difficult all of these different things are to produce. And then if you're making this chip, like if the mirror is off by like a nanometer, then it's just going to not print anything useful at all. So it's like so many things that have to be right at the same time just to print like a functional chip, because we're talking about like atomic scale manufacturing today. Like this is incredibly impressive how far humans have come, and like being able to actually like manipulate atoms to like make them think or like make them run this video call, etc. So like there's a crazy feat of engineering that has gone into like semiconductor engineering, and this has meant that there's like these huge monopolies like ASML, which is the only company that can produce EUV lithography machines, or like TSMC, which has like 80% or so of the market share of like advanced nodes, and then also Nvidia, which are they aren't even producing anything. Nvidia is like sending their order to TSMC, but Nvidia is doing the design of like the circuit on the circuit board on the chip, and that is also like an incredibly intricate thing where you have like a three-dimensional structure. There's so many like dimensions in which you can optimize the structure to like get the outcome. There's like so many layers of architecture. Like you need to think about the number of cores and like what each core is doing, etc. So there's like a lot of complexity to every single part of the supply chain. So I think it's kind of hard to convey. And like I've obviously never worked at a fab myself, but like from what I've heard from people who have, it's like really crazy, just like how people have dedicated like part of their life just to figure out this one part of this one machine that's just producing this one type of wafer, and just to like increase the yield of that, or like make it possible to also produce that. And I think that is why it's so hard to pass this on and to replicate this.
Hmm. So is it possible to roughly say how far behind, like how many years behind China is to do this themselves?
Yeah, I mean, my personal best guess is that EUV is really the biggest challenge for China. They're like, it's a funny story because
Is that what ASML does?
yes, that's what ASML does. When ASML was first like trying to produce this, there were two Japanese companies, Canon and Nikon, and they were also trying to produce EUV. And all three companies spent like more than a decade trying to do it. And ASML was the only company that succeeded, and Canon and Nikon, they just failed. They just couldn't do it, so they dropped out of the market entirely. So there's only this one company on this planet who knows how to produce these machines. And I think it's just a really far stretch that China is going to produce like a EUV machine domestically in the next 5 years. So I think it's like at least 5 years until it is able to produce these kind of EUV machines. Like that is roughly like maybe it's 10 years, but it's definitely like a couple years down the line. And then there's like so many other things. Like even if you have the EUV machine, you need to be able to use it effectively. And like you have to not just build one, but you have to build like, I don't know, like 20 or 50 or so of them to actually produce chips at the scale that like TSMC is and the rest of the world is. So it's like first you need to produce the technology, and then you need to scale the technology to an industrial scale to actually like make it happen. So my best guess is like to produce all the machinery that we have today, it's like at least 5 years in China, and hopefully at that point we'll already be at the next step in technology, and then China will like take another 5 years to get there.